Hey class, I just wanted to shoot you a quick video on example 3 from the textbook from section 8.4, the point slope form, which is the whir problem. I wanted to go through this problem with you so I can kind of explain it to you so that we understand what's going on. All right, so let's take a look. So example 3 says here, suppose that that laser eye surgery is modeled on a coordinate grid. The laser is pointed at the y-intercept so that the light shifts down 1 millimeter for every 40 millimeters it shifts to the right. The light reaches the center of the cornea of the eye at point 125.0. Write an equation for the light beam in point slope form and then find the height of the laser. All right, let's take a look and back at the problem and figure out what information that they actually give you. Okay, so the first sentence says we're talking about actual laser surgery, and we have a laser that's shooting into somebody's eye. And what we're given first in the second sentence, it says that the laser is pointed at the y-intercept so that the light shifts down 1 millimeter for every 40 it shifts to the right. So right there, that actually describes the slope. So remember our slope, that's our change in y or change in x, the rise over the run, okay? Or how many times we go up or down versus how many times we go left or right. So when it says that they have the laser and they're pointing it so that it shifts down, which is y, okay? 1 millimeter for every 40 millimeters, it goes to the actual right. So notice, so that's our slope, the change in y over a change in x, -1 for every 40 millimeters to the right. Okay, so what that actually describes is the steepness that they're pointing this laser into somebody's eye, basically. My dad got eye surgery too, and they fixed that cornea where he didn't have to wear glasses. Okay, all right, so that's my slope, -1 over 40. Now it says here that the light reaches the center of the cornea of the eye at 125.0. So that's the x-intercept, is that point 125.0. Okay, that's where the person ends up having their eye, like on the grid. So remember that this is your x1 and this is your y1. Okay, so we have the steepness of this laser. It's pointing -1, 40, so it's going down 1 for every 40. Describes the line, and then it stops at that 125.0, which is the center of somebody's eye. Now, what they want is an equation in point slope. So we know point slope is the y minus y1 is equal to your slope times x minus your x1 value. So I'm going to plug in my slope and plug in my point to create my equation in point slope form. So here I have y minus my y1, which ends up being 0, is equal to m, my slope, the steepness of the line, so they're pointing the laser and it creates the steepness at -140, times in parentheses x minus x1, which is the 125. And just to kind of clean it up a little bit, anything time or subtracted by 0 or added by 0 ends up being itself. So the equation would be y is equal to -1 over 40 times x minus 125. So that's our equation in point slope form. But the other thing that they want is to find the height of the laser. Okay, so I'm going to attempt to draw a picture of it real quick just to kind of show you what they need. Okay, so we have they're saying we have it's modeled on the coordinate plane. Okay, I have the eye, so if I did 25, 50, 75, 100, 125.0, that's my eye. That's at the center, okay? And what's happening is that we're going down 1 for every 40, down 1 for every 40. So down 1 for every 40, and this is my laser. Okay, so just imagine everything's on the line here, okay? So what we're looking for, it says, what is the actual height? Okay, so I have to find the y-intercept. Okay. Now remember, back from section 8.3, that y-intercept is when x is equal to 0. Okay, so we know the y-intercept is when x is equal to 0. Notice x is 0, what then is y? I have my x-intercept when y is 0, but my y-intercept is when x is equal to 0. So what I'm going to do is now take my equation from point slope and now plug in my value. So I have y is equal to negative 1 over 40 times x now, which is 0, minus the 125. Well, the 0 cancels here, so what I'm left with is the negative 1 over 40 times negative 125. So when you stick that into the calculator, okay, you end up getting 3.125. And that ends up being the height of the laser when x is 0, y is 3.125. So that's where they started the laser in terms of height. And they shot at the eye, which is at this point, that 125, 0. Okay, and the slope of the line, the steepness of the line, is at negative 1 over 40, down 1 and to the right 40.